everyone understands what we're doing here. Okay, so the notes on your screen are what we call the HVAC training program. It's a fairly basic program and really designed initially for people who have just entered the industry and are getting familiar with the way things are done and general terms and also the process that we follow. MEPAC is in the contracting side predominantly. So there's a process of starting from day one and going all the way through to commissioning, producing maintenance manuals, and then looking after the project during the warranty period. Thomas and Bilal, you're with consulting engineers, I believe. Is that right? So the process for you will be slightly different, but the principles of what we're talking about are still relevant. And I think it's probably worthwhile for you to understand the process that we follow. So you guys, and including Hudson, have not been involved with quite a few previous meetings. So we've been following a process where we started talking about where we fit into the building industry and who the participants are, how the workflows occur, and you guys would already, I presume, be involved in this sort of process. So in our last meeting, we've been running a series of half-hour meetings because we feel that at the moment that's enough to absorb in one session. Last week we talked about electrical systems. So in our workflow, firstly we produce an equipment schedule, which is all the equipment in the HVAC project. And from there, we produce an electrical schedule, which is, I can show you the schedule, but it probably won't mean a lot. But that's from the equipment schedule, we fill in this schedule, which has got all the electrical data for the equipment, what its power ratings are, how it's controlled, etc. So we do that, and then we've got a full list of all the equipment, and then from there, that schedule is issued to our electrical subcontractor, who produces drawings which show how everything's wired, which switchboards they come from, and how they're controlled. So after we've got all that underway, and also the electrical contractor, we've got another participant. Hello, Stephen. I'm Peter.
Hey, Peter. Nice to meet you. Thank you for organising this.
You're welcome. Thanks for joining. And we've got Dua and Hudson from MEPAC.
Hello.
And I presume you know the other two guys.
Yep.
Okay, so I've just given a bit of an introduction. You can have a look back at the video if you want to get that background. But so we're just following a process. One of the things that I've always kept in my mind through my whole career, and we've got another one, Ellen. Hello, Ellen.
Hi.
I'm Peter.
Thank you for having me.
And so something that's always stuck in my mind, that everything you do is a process, okay? All the work you do is a process. You start from A and you finish up at Z, and hopefully you haven't forgotten anything on the way. So, but it's a matter of developing steps to get to the end so that you don't miss things and so that you do a thorough job. So having been through the electrical, we come to the control of the HVAC equipment. So in order for the HVAC equipment to perform its required function, control systems, generally called controls, are required. I don't know what sort of projects you guys from MEPAC have been involved with, but just bear with me. If you want to ask questions anytime, feel free to do so. That's fine. And the controls are required by the wiring system that we've been talking about in the previous session. So their power supply comes from there, but then they're wired out to all the all the sensors and equipment in the field. So they things such as temperature and relative humidity sensors, air and water flow rates, pressure, fan and pump speeds, CO2 content of the air, start and stop times. All those things are controlled, and lots of other things. So you've got lots of sensors out in the field. And we're probably talking about a large project, but even on a small project, you've still got the same sort of systems operating. So control systems for small projects are normally electronic. And I've got a picture here that I can show you. At least I had one. Sorry. Yep, here we go. So can you see that? This is just a Mitsubishi page that I got off the internet. These two devices here are centralized controllers. When you have a number of, say, a VRF system and you've got a number of fan coil units throughout a building, they can all be controlled through one of these central controllers. I don't know whether you've come across that. Then you've got a wall-mounted controller, which might be used in a domestic situation, residential, or a small office, for instance. This one here is probably more a residential one. In fact, I've got one of these things in my home. It's a zone system, so I can control the zones, the temperature, well, not the temperatures to each zone, but I can control which one's open or closed, and go for heating or cooling and adjust the temperature. This one's got chopped off, but you've probably all seen those. The handheld controller that you can use at home. And there's various other things. So they're more for smaller projects or small commercial projects. This device here is a building management interface or a DDC controller. We're going to talk about that a bit more in this session. So at the moment, I'm not sure what projects you're working on. I know that the MEPEC guys are not getting too involved in BMS right at this moment, but from various times, depending on the size of the project, we will. So that's what I wanted to talk about. And the idea is to give you an awareness of what's involved. If I wanted to, or if we were going to learn a lot about DDC and BMS, we'd probably be here for at least a week. So we're here for half an hour, so you can understand that we're just touching the surface, but it's creating awareness. So if you wanted to learn a lot more about this, you can get on the internet and you can find, books and books of information about DDC and BMS. So if you want to go and learn more about it, it's all out there. There's no shortage of information. Larger projects normally are controlled by a building management system, BMS. Has everyone heard of a BMS? Just nod your head if you have. Which is a computer-based system controlling the HVAC systems via direct digital controls, or DDC. I'm sure you're all aware now that in this industry we've got lots of little abbreviations for different things, and you get familiar with them after a while. So BMS and DDC is something that you'll see again and again. And the BMS also monitors or controls other building services such as lighting, hydraulic pumps, vertical transportation, and so on. The DDC does the control of the HVAC. The BMS is the overriding control for the building and monitors and can send the signals out to external places. Control signals can be analog or digital. Analog control means the control signal is variable, such as fan speed control, or temperature, or humidity. So it's a variable signal. Control signals are usually 0 to 10 volts DC or 4 to 20 milliamps. So it's usually 0 to 10 volts DC for an analog signal. So it's variable from 0 to 10 volts. and low voltage too. So there's no risk of electrocution with the controls. They're normally 24 volts DC AC power, but low voltage control signals. Digital control means the control signal is on or off, such as fan start or fan stop. Now I've got a schedule here that we can have a quick look at. This is a DDC points list. Has anyone seen one of these before? So I mentioned analog inputs and outputs, digital inputs and outputs, and then there's HLI. HLI is a high-level interface. Some equipment manufacturers can provide a high-level interface which takes information out of their proprietary control system and makes it available to the BMS. So instead of having lots of inputs and outputs, you might get, for this case, for instance, there's 10 points that you can pick up off a chiller. So that might be temperature, pressure, power consumption, all those sorts of things can be provided through the HLI. Variable speed drives, or VSDs, also can come with a HLI, so all that data can be sent straight to the BMS. So, as I said, analog inputs, these are inputs to the DDC controller. Room CO2, room temperature, room relative humidity, and so on, filter pressure. Analog outputs. So the inputs come into the DDC controller, and then the controller sends a signal back out to the device that's being controlled. So if you've got a system with heating and cooling coils, which operate with chilled and heating water, they'll have a cooling valve, a heating valve, and various dampers. So the outputs from the DDC controller to those items are analog outputs. Does that make sense? Because it's a variable signal. It's not just on or off. It's a varying signal depending on the strength of the input. So the temperature sensor might send a signal to the DDC controller saying that we need more cooling, but it will also give a 0 to 10 volt reading. So let's say it's 5 volts. That means you've got 50% call for cooling, if that makes sense. Okay? You're not full cooling, you want half cooling. So that will then tell, the DDC controller will tell the valve, just in round terms, open 50%, okay? And then there'll be this constant input, output. Oh, that's not enough, open it a bit more, that's too much, close a bit. So this is happening all the time, this analog signal in and out. With the digital inputs are discrete. It's on or off. So if so this one, for instance, supply fan start or stop. The DDC, through a time program, let's say, says time for the fan to start, and that's closes the relay in the electrical wiring system, and the fan will start. And then this one, supply fan status. Sorry, so the start stop signal is a digital output from the DDC controller. Okay, there's an input back into a digital input back to the DDC controller, which might be from a relay or from an air pressure switch that sends a signal back to say, yes, the fan has started. So it's a confirmation that the fan has started. So the DDC system knows that the request has been performed and everything is working. Now, next one, supply air fan speed. Again, that's an analog output. HLI. So that's a typical air handling unit. Now, there's a lot of points in there. You may not have all those points, but it's a bit of a guide on the sort of things that you might need. This is a different type of air handling unit, variable volume unit. Once again, analog inputs, temperature, humidity, outputs, valves, dampers, same sort of thing. HLIs, VAV boxes quite often come with an HLI available. fan coil unit. So, excuse me, a much smaller unit. So not as many points, but still the same types of points, temperatures, outputs to cooling valves, heating valves, fan start and stop, etc. So that's pretty typical of the sort of points you have. Chilled water system. Have you guys from McDonald done much with chilled water at this stage in air handling units?
I've personally only seen a points list on one project so far, and was a refrigerant-based project.
Okay. All right. So, well, these are the sort of things you will come across. And as I said at the start, the idea of this is to give you an awareness so that you know how it works. So I've got some diagrams of this one, for instance. When you with your DDC system, perhaps I'll show you a different one first. That's a bit hard to see. This is a very simple schematic of a DDC system. This is not a BMS, this is a DDC, okay? So you have a computer which has got all the programs put into it for how things are meant to operate. It's all preset. And within that interface, we'll just jump back to that other one, you have graphics such as this. So if you want to look at a particular air handling unit and what it's doing, you can pick that up off the computer and have a look at all the temperatures. So you can see here, there's a temperature sensor here for the return air, temperature sensor for supply air. These are the cooling valves. Cooling valve here, heating valve there. This gives you an idea of the percentage open. So the heating valve is 50% open, the cooling valve is closed. Obviously, you don't have both operating at the same time. This is the supply fan. It's on, so you can have on and off. This is a temperature sensor at of the mixed air coming into the fan, etc. Over here, that's the filter on the return air. This is a pressure sensor measuring the pressure drop across the filter, which when it gets to a certain preset level, it'll send a signal to the DDC and then to the BMS to say the filter is dirty, it needs to be replaced. Okay, that's quite common to have that. Over here, you've got the outside air temperature, and quite often you'll have outside air temperature and humidity in the DDC, which can control economy cycles and things of that nature. So back to here, you've got these DDC controllers, which are getting inputs and outputs from the computer, or sometimes called an operator machine interface. And that's connected to the internet as well. And out here, you've got zone controllers, equipment controllers, and then all the sensors. I've got a picture of this is a typical DDC panel. These light-coloured boxes are the DDC controllers. You can see all the wires coming in and going out, and lots of wires up the top here, which go off to the computer to send signals and receive signals. So these panels here, the DDC panels, receive inputs, analog inputs and digital inputs, and send out analog outputs and digital outputs. So they're the things controlling what's happening out in the field with all of the equipment. The HLI, a high-level interface, is something that goes directly from the HLI. Actually, with a HLI, you need to have an interfacing device to convert all those signals into the DDC so that it understands what you're talking about. There's lots of different types of DDC systems. There's BACnet, which is probably the most common and accepted as the one that's used internationally, but there's also Longworks and there's others as well. But quite often Honeywell, for instance, will say that their system is totally compatible with anybody else's. So you can have a Schneider controls and mix with Honeywell. In practice, it doesn't work very well. So you're usually better to have all the same controls from the same company. Otherwise, there's going to be trouble. Okay, but with a high-level interface, let's say it's a Honeywell control system and it's a trained chiller with a high-level interface. You'll always need something in between the two to convert the signals from the controller to the DDC control system so that they can actually work together. That's just something to be aware of anyway. Okay, so what else have we got? Go back to here. Well, really, that's, apart from just showing you things, that's all I was going to talk about this morning. I'll just show you, I couldn't get a very good graphic of this. This is a BMS system. Automated Logic is one of the big players in the industry, controls industry. It's very difficult to see, but you can see on here that there's a light there. So this is where the BMS only sits over the top of the DDC system, but also other systems in the building, and gets inputs and may provide outputs to all the other building services. So you've got all the devices down here, DDC controllers, DDC computer, etc., etc. So that one's a little bit hard to see. Any questions?
I've got a question. Are these control panels, these DDCs, usually located in like the plant rooms and basements, or
Yes.
where would you usually find them?
Yeah, no, that's exactly right. So this panel, they usually sit beside the mechanical services switchboard. So hang on. Was that you, Thomas, who asked that?
I was Stephen.
Who asked that question? Sure. Stephen, was it?
Yep.
Sorry, I had something on my screen that was blocking the picture. Yes, yeah, they're normally in the plant room. Sometimes, say for variable air volume boxes, VAV boxes, have you guys done anything with VAV?
Yep.
Sometimes the DDC controller will sit on the VAV box itself. Okay, that just saves having a panel. And some controls companies, I know Siemens, for instance, but the others would have them as well. Siemens produce a special VAV box controller, which is a DDC controller, which talks straight to the computer. So that saves having an intermediate control panel somewhere else.
So on this
Any other
image
questions?
right now, are you able to point out like how many points there are? Like, are you able to look at this image and correlate that with the number of points on the point list?
I can't read what these things are, but I would say that the inputs are on one side and the outputs are on the other. So I'm not sure which is which, to be honest. So it's probably, let's say the inputs are at the bottom. So these are the inputs from, say, temperature sensors and pressure drops across filters, airflow or air velocity sensors, things of that nature.
Mm-hmm.
And then at the top, all the wires go out to the computer and come in from the computer. So the computer has all these graphics that I showed before. Obviously, it's got a lot of data, but you can look at a graphic screen, and normally these are either a touch screen or you can do it with a mouse. You can go to this temperature, and you can make an adjustment. So you can make it higher or lower if you want to change something. just as an example. But on a large project, you'd have maybe 100 or more graphic screens of different equipment in the field. And you'd also have each floor of the building, or each area of the building would have temperature sensors, CO2 sensors, relative humidity sensors, all shown on the graphic of that floor. And you can look at them and see. It's a good way to identify if there's a problem, because you can look at a floor and say, oh, hang on, the temperature over here is 30 degrees, but everywhere else it's 23 degrees. There's a problem there. Something's not working properly. It might be a fault with the sensor, but sometimes it's a fault with the equipment that needs to be rectified. So it's very good for problem solving. If if somebody calls in and makes a complaint and says, the temperature's too hot in my zone, you can jump onto the DDC, have a look at that zone and say, oh yes, it's 30 degrees, and then you might be able to see that, oh, a VAV box hasn't opened, or a heating valve is open but it shouldn't be, or vice versa, cooling valve is not open, things like that. It's a very good diagnostic and problem-solving tool. And so that's on the computer itself, so on the operator machine interface. This is where, in the control room or security room, wherever they decide to put this, all those graphics are displayed there, and an operator can look at what's happening right throughout the building. And so I got off the track there, but no, the answer is I'm not sure how many, but you can see how many terminals there are on that diagram. So there's 2, 4, or about 10. Now I'm not sure whether they might be, say, analog inputs. Over here, they might be digital inputs and digital outputs, analog outputs. I'm not sure. And this is communicating with the computer. The best way to really get a good look at it is to get in contact with a supplier, say Honeywell or someone, Schneider, Siemens, get them to come in and give you a talk about, and bring some hardware with them, some of these devices, and get them to explain in more detail how those things work. And that's what we try to do, is to get the suppliers to come in and show us their stuff. And the same thing with electrical systems. We'll get a subcontractor to come in, explain wiring diagrams, talk about all the switchgear involved, and tell us how that works. Is there anything else that I could tell you now? We've sort of come to the end of the half hour, but I'm happy to answer some questions if you have any.
So for example, these ones, Honeywell has these box-looking things for the AHUs. Would that be like a pre-made thing that they just provide for each air handling unit? And then depending on how many points you specify, that would determine how many wires are being put in?
Exactly. Yes, that's right. So you're talking about this DDC controller here that I've got the pointer on?
Yeah.
So for each, so you can see they're labelled there, AH3 Chapel, AHU1 Church. They're all exactly the same. This is a bit different. This one here, plant/miscellaneous. That's a smaller one. I'm not sure why they would have put that on, but they probably don't need as many inputs and outputs, so you can get different sizes. But if it's an air handling unit, they would just select those. If you've got 50 air handling units, you'd have 50 of these DDC controllers. These other ones might be for something else. It might be for a boiler. It doesn't actually say what that's being used for, but there's a device over here, boiler integration. I'm not quite sure what that is, but it's some sort of interface between the boiler and the control system. So yeah, does that answer your question?
Yeah, thanks.
Yeah, and as I said before, the VAV boxes, you'd have something similar to this, but smaller. So something like that sitting on the side of a VAV box, which is getting inputs and providing outputs to control the VAV box operation. It just simplifies it a bit, so you don't have to bring it all back to a control panel. It goes straight to the computer to be analysed, and then the signals come back through the DDC controller back to the equipment. Anything else?
I'll probably ask one last question. Would
Yep.
there ever be these individual controllers that would be connected to like essential services and would be required to operate in extreme situations like in fire mode? And in that case, would you need like separate in a separate panel or not?
Okay, so some systems can be very complex, and that's a very good question. Generally, what happens if there's a fire alarm is that all the fans, whatever has to work in a fire mode, stair pressurisation fans, smoke exhaust fans, will be all hardwired, which means through relays, directly wired from the switchboards. The control system, really, the DDC system doesn't have anything to do with control in the fire mode, because if it fails, you've lost your safety systems. So they're generally hardwired, and they're hardwired with fire-rated cable. Okay, so they try to make that as safe as possible. It's all controlled by codes. AS 1668 Part 1 spells out how that has to be done. But the DDC and BMS may monitor what's happening. They might sort of mimic and give you a display of what fans are running. So they might say the stair pressurisation fans are on, smoke exhaust is running, so on and so on. But they won't be controlling them. The controls are all separate to the BMS. And what we say hardwired, which means they're directly wired, not through a control system, not through a HVAC control system of this nature. So does that answer your question, Stephen?
Yep, thanks.
Yeah, that was a good question, because that's important. Anybody else? Okay. Well, look, our next session, normally we run these on a Tuesday at 10 o'clock for half an hour. So going back to this, our next session, we're going to talk about fire safety and fire matrix. So Stephen, you're one step ahead of us. So next time we'll talk about that. Again, it's going to be fairly high level, because to go into that in great detail requires a full understanding of AS 1668 Part 1 and 2 and the BCA. But I'll mention those things, and you can do your own research and you'll learn in time. Don't expect to learn everything straight away, because there's so much to learn. You'll pick it up over time, talk to people, ask questions, do some reading on your own, and you'll gradually get to know these things. But that's what we're talking about next. So when we do a project, we prepare a fire matrix, which is also part of the process. Once the electrical schedule has been done, we can transfer all that information onto a fire matrix to show what happens in a fire mode. Okay, what runs, or what starts, what stops, what dampers open, what closes, and so on. So we'll talk about that a bit next week. It won't be in great detail, because again, to go through that would take hours and hours, maybe a week. But we'll touch on it just so you've got an awareness. Okay. All right. So any other questions? All right. Well, before we finish, would you all like to be invited again next week?
Yes.
Well, I'll just send out a general invitation to you, and you can accept, and hopefully my system will behave itself next week, and we'll get off without any hitches.